Alright, today I'm just making a quick little video to talk about some of the things that I feel like are major themes going on in AI right now in terms of large language models, transformers, stuff like that. I pulled up this video, this paper because I think it has a lot of the things that I'm going to be talking about. Obviously, there's going to be a lot of things that I'm missing. I've only read so many papers, and there's so much that in so many areas I'm not going to be covering. I'm just going to be talking about kind of the structure of LLMs that I think are interesting and will be are the main topics and will be the main things for the next maybe like 6 months to a year to kind of perfect. So this paper is about a really tiny neural network compared to state-of-the-art models, but it's got a couple things that I think are really good. So recursive reasoning, recursion, main word there. I think recursion is a big thing that will be very necessary for shrinking models. DeepMind has a paper on recursion. These little models are using recursion to keep small, but still working very well. To caveat, it is in their certain domains, it seems like. But, so recursion, this paper also has a lot of its reasoning is in the latent space. I think a main thing we're going to be moving to is rather than thinking in token space. I mean, this is already a thing in many papers of moving to latent space. Rather than thinking in token space meaning tokens or words or images, rather than thinking in that, you do like somewhat like what the human brain does. You don't do a lot of your thinking computation in words. You do it just, which I think it's mostly unconscious or subconscious, that you think in latent space, understanding things. So that's the second part. Those are two parts: recursion and latent reasoning. And then let's see. Oh, the other thing that's in this paper. So yeah, it kind of has all the main things of the structure that I like. It also references hierarchical reasoning model, a different paper, which hierarchy is the other thing. This one has it uses the same not architecture, the same neural net for both the lower level and the higher level. I'm not sure if that's going to be the end way of doing it, but yeah, let's see if anything. So yeah, here's kind of what it does. It thinks at low level, and then high level, low level, and then high level. So yeah, I think hierarchy of having low level stuff and then high level, working at different temporal frequencies. I think those are going to be really huge and are really huge things of research right now. Let's see. I think that was pretty much it. Pretty much the main things on architecture, which I do wonder if it would be even better to have maybe 3 levels. It would be computationally very difficult, I'm sure. But yeah, I think if you mix maybe having 3 levels and they all think in latent space rather than thinking between each token, you'll have a latent representation that you can kind of not diffusion kind of diffuse, but you can diffuse into like 4 or 8 or maybe even up to like 16 tokens at a time. But yeah, so hierarchy, recursion, latent space reasoning. Should have written this down.